Yo, what's up, people? Today we're talking about increasing annuities. So this is just a follow-on from the previous videos where we calculated present value of annuities. So now the only difference is these annuities are increasing, specifically geometrically increasing. So each payment would increase by percentage. But it's not as simple as it may seem because we must be accounting for interest and growth at the same time when we present value. So that's where this lovely formula at the top here comes in and the calculations start becoming fun. So over here, I don't have much to say about this, but all we really need to do is calculate the J, which is the interest rate that's also accounting for the growth. And by using this formula, we can do that. So 1 plus J is equals to 1 plus I over 1 plus G, where I is the interest and G is the growth, and we must just make sure that the I and G are in the same period, like monthly or yearly, whatever it is that we're doing. So something that I want to mention about the J's, and I'll write it down. So all that I've written here now is that when J is positive, the payments are growing slower than discounting. This means that the discounting is stronger, so our present value is going to be smaller. And then when J is equals to zero, the payment growth offsets discounting perfectly, meaning that each payment is going to be equal and we're not going to see growth. And then when J is negative, payments grow faster than discounting, which means that growth is going to be stronger and the present value is going to be larger, if that makes a bit of sense. So all that we're doing here is going to calculate J, and then we can treat it as a normal level annuity with interest rate J. So that's all I can say about it. Let's jump into an example. So now I'm going to start with a timeline here. That's always a great place to start. So no, this is time 0, 1, 2, 3, all the way up until year 7, which our payment would be at the beginning of the year, at the end of year 6. So the first payment we were told is how much? 100. Our second payment would be 100 multiplied by the growth rate, and the second one would be 100 squared, and so forth. So our last one would be 100 g to the 6. So let's just write the interest rate here. 9%. This is our annual effective rate, and then our growth rate per year is going to be, where is it? 4% each time. So each end these are annual payments. So let's quickly calculate the J. J is equal to 1 plus I, 1.09 over 1 equals to, pop that in a calculator. Nice. So now let's write this out in first principle, see what we're working with. Present value is equals to 1. And I must also discount that to times 0. So now this is a mess, the G, V, a lot going on here, but now we've got a J to work with, so let's do that. So now let's take that 100 and see what we can make happen. This should be familiar. We'll use the annuity in advance formula. Remember, there's 7 payments, even though over here we've got a 6, but there's 7 payments. This is just an advance. The first one isn't being discounted. It's at times 0. And our interest rate is going to be the J. So I'm just writing J's because this number here, I'm not rewriting that. Now we'll just pop that other formula in. And when we put this into the calculator, we get nice. So that's our answer for the first question. Let's check what the second question is asking. An annuity will have its first payment 5 years from now in advance. The first payment will be $500, followed by monthly payments, each increasing by 2% for the next 3 years. Interest rate is 9%. Oh, it's a mouthful, but it's fine. Start with our timeline. They say the first payment is at 5 years, so we know that we're gonna have to present value this by 5 years. So let's act as if this is our time 0. So we'll just work from here and then present value it to time 0. And they're saying it's in advance. So as soon as we get there, we're getting a 500. So let's put a 500, followed by monthly payments increasing 2% for the next 3 years. So monthly payments for 3 years. So this is going to be 6, 7, 8. We're going to have payments for these 3 years, and these are going to be monthly. So that's a whole lot happening in between there. So we'd have a total of what? 36 payments. So, a lot going on here. Let's calculate J. J is equals to. Now we must remember that we need a monthly interest rate. Now we have the annual. So let's go to the side here. I monthly is equal to 1.09. So pop that in a calculator. That's going to be there we go. So now we can that's also, I'm going to call this variable a because I'm not writing out that whole thing. It's going to be 1 plus a over our growth rate. Yeah, we're going to keep it 1 point because that's the monthly one. That's what they gave us. Minus 1. That equals to negative. Yay. So, okay. This is the J that we're working with, negative. That looks weird, but it's fine. Let's not freak out because remember previously we said that J can be negative and it's going to have that effect. So let's continue. Hopefully it works out. Otherwise we'll go check what we did wrong. So now that we've got J, let's write this stuff out in first principles. Present values equals to, first one is 500. 500 growth and discount. Growth, discount, but these are squared. Now this growth and discount is going to be to the power of 35. How I got that, remember we said that there's 36 months in 3 years, right? And these are monthly payments. But yeah, this GV, this thing, there's too much. Let's go 500 plus. Say 500. And now, I hope you know that. You can see that it's the advanced annuity formula now. And we're working with the J that we calculated in the box, the negative that we're trusting. Okay, now putting this into the calculator. And you're allowed to do this. You're allowed to write this J here. Because we indicated here that the J is that number. So it's not like I'm doing nonsense here. But let's continue. We'll pop this in a calculator quickly and check our answer is Cool, but this is not our answer. We've still got some magic to do. We have to just present value this by another 5 years. So how are we going to do that? How are we going to do that? What we're going to do is present value. That's just the answer we got just now. And now we're just going to discount it by 5 years. So it's going to be 1.09 to the negative 5. What I did here is I used the 9% that they gave us. That's the annual effective interest rate. So I'm just discounting using that interest rate. So I'm using the 5 years. I'm not working in months. Remember the period and the interest rate, the term, that stuff has to align. So now we put this into a calculator. We get an answer of 14,716.0. And that's our answer. Thanks. So the second question was slightly more complicating. However, I'll do some more questions in another video, some more examples where perhaps these G's and these V's aren't aligned. So maybe this would be 500 G V squared plus 500 G squared V3, where they don't line up. So just off the top of our heads, we can see that to make this work, we would just factor out one V, because then if we take out one V, then it would be GV, and this would be GV squared, and this would be GV to the 1, because we take out a V like that. But we'll get to that, maybe try a few examples yourself, find something, head to the next video. Thanks.